Okay, so up till now, everything we've done has not had an equal sign in it. All the radical work, we've been adding radicals, we've been multiplying radicals, we've been squaring radicals, we've been using FOIL, we've been simplifying radicals. There has never been it's never been an equation. When you have a radical equation and you want to solve it, so that's what we're going to talk about, solving radical equations. They're really very simple from my perspective. Very, very simple. So if I had the square root, okay, the first problem, start very simple. The square root of x is equal to 7. Well, as long as my square root is the only thing all by itself on the left side of the equal sign, then I can square this side. Remember what squaring does? Squaring gets rid of your radical. They cancel each other out. When the square is on the outside of the radical sign, they cancel each other out. So the square root of x, if I square that, then that's going to cancel this out, and all I'm going to have left is x. But I have to square, if I square one side, I have to square the other. So really, square root of x squared becomes just x equals 7 squared is 49. Pretty straightforward. Let's try another simple one. What about square root of 20x equals 10? 20x equals 10. Well, I see I have a radical sign, and that's the only thing, a radical sign and then stuff underneath it. It's the only thing on this side. That is already isolated. There's nothing else to the left or to the right of it. It's totally isolated. Therefore, I can square both sides. By squaring both sides, it gets rid of the radical sign and the square, basically, and so all I have left is what's inside the radical, which is 20x equals 10 squared is 100. Now I'm supposed to solve for x, so I'm going to divide by 20. Divide by 20, x is equal to 5. Not hard, right? So, okay. Now what if, again, you can pause this and write things down if you need to in your notes or whatever. I'm just going to keep moving here. 3. What if I gave you something like this? The square root of 2x minus 5 is equal to 7. Well, is this radical isolated on this side? Actually it is. Look, that's the only thing. It's the radical, and everything in it, everything on that side is underneath that radical sign. So that is isolated. As long as it's isolated, I can square both sides. Alright, so squaring both sides just gets rid of the radical sign and the square. They both cancel each other out. So all I have left is what's underneath the radical sign. So I have 2x minus 5 is equal to, what's 7 squared? That's 49. I put 49. I just solve for x now. I add 5, I have 2x is equal to 54, right? And divide by 2, x is equal to 20, 14, 7, I think. Sounds right. So there we go. That wasn't so hard. Now what if we did, here, I'm going to come over here. I hope I don't have too much of a sheen on this side of the board. We'll try it. What if I gave you something though like this? The square root of x plus 6 equals 11. Now, if I squared both sides right now, I'd have an absolute mess. because what I'd have to do is I'd put this a parenthesis here and a parenthesis here, and I'd put square, and I would have a binomial. And squaring binomials means I'm going to have to use FOIL. That would be a mess. It would be a mess. So remember my rule over here, as long as the radical is isolated, meaning it's the only thing on that side of the equal sign, then I can square it. Alright, here's my radical. Is that the only thing on this side of the equal sign? No. The 6 is in the way. So I'm going to get rid of the 6 by subtracting it. So now I have the square root of x is equal to 5. Now that is easier because now it's isolated. So if I square it now, I will get rid of my square root sign, square this, I get x is equal to 25. Let's try another like that. I'm hoping you can see that on the video. Alright, so let's try this one. The square root of 4x plus 13. 4x plus 13, and then it says minus 1 is equal to 8. Okay, so again, is that isolated? So that there's nothing else on this side of the equal sign other than this? No, this doggone negative 1 is in the way. So I'm going to add 1 to both sides, and that's going to give me the square root of 4x plus 13 equals 9. Now that's isolated, right? That's radical sign is isolated. There's nothing else after it or before it. So I'm going to square that, and I'm going to square that. So that gives me 4x plus 13 equals 81. I'm going to subtract 13, so we've got 4x is equal to, I don't know, what is that? 9, 11, so that's 8, and then that's 1 from 7, which is 6, 68, right? So then I'm going to divide by 4, I hope I did that right. X is equal to 4 goes into 6 once, with 2 left over, so 28. 4 goes in 28 7 times. So it looks like I got 17. X is 17. The key is make sure that's isolated. So move that over so that this is isolated. Then you can square both sides. Now I noticed on the test a ton of people when, this is sort of like a little intermission here, ton of people when I gave them like a problem, I'm trying to think, like, you know, the square root of 4x over, you know, the square root of 10. They did this. They squared the top and they squared the bottom, and then they got 4x over 10. Totally doesn't work that way. The only time you can square two sides legally is when there's an equal sign. Because you have to use the golden rule of algebra. Whatever you do to one side of the equation, that means it has an equal sign. Whatever you do to one side of the equation, you must do to the other side of the equation. There's no equation here. This is just a fraction. So by squaring both top and bottom, you just change the fraction. Right? Totally change the fraction. If you had just to prove it, if you had a fraction 2/3, and you squared it, right, that would give you 4/9. Is 2/3 equal to 4/9? No way. Totally different fractions, right? So you can't do that. You just can't do that. When you square, like that, you've got to make sure you have an equation. So that's that. Let's keep going. Where were we? 1, 2, 3, 4-ish. Uh-oh. I lost track. 1, 2, 3, 4. I don't know. Where were we? I have no idea where we were. What number I was on. 1, 2, 3, 4, 5. I'm going to just say 6. I don't know. I could be way off. Alright, so what if I gave you something like this? The square root of 5 minus x is equal to the square root of 6x minus 2. Alright, so now we have radicals on both sides of the equal sign. And I have, this is isolated. There's nothing else after this or before it. It's totally isolated. Ah, but look at this. That's also isolated on this side. There's nothing before it, nothing after it. That's isolated. When they're isolated, I can square them. So I'm going to square both sides. That's the golden rule of algebra. What I do to one side, I must do to the other. That gets rid of my radical sign, and now I have just a very basic multi-step equation. I just write the same thing, except without the radical signs. And I solve. I add x, add 1x. I've got 5 equals 7x minus 2. I'm going to add 2. So 7 is equal to 7x. Divide by 7, x is equal to 1. Alright? So, very, very simple. Boom, boom. Right? Now, what if they're not isolated? Hopefully I can find one of those on here. What if I had something like this? 0 is equal to the square root of 2x minus the square root of x plus 3. Over here I have a 0. Here I have a radical sign, but it's not isolated because there is something after this radical sign. There's a minus sign and there is a whole nother radical. If I FOILed this, if I squared this side and squared this side, it would be awful. It would be a nightmare. I wouldn't want to do that. But since it's just a radical minus a radical, what if I moved one of them to the other side? Since it's a 0, it should be very easy to do. I'm going to take the one that's negative, and I'm going to add that one. X plus 3, add the square root of x plus 3. So that gives me the square root of x plus 3 is equal to the square root of 2x. Now I have a radical all isolated on this side, and I have a radical isolated on this side. I'm going to square both sides now. And that gets rid of my radical sign, Remember, square cancels out square root. So x plus 3 is equal to 2x. Subtract x from both sides. I have 3 is equal to x. X is equal to 3. Pretty simple. Okay? I think that is about it. I mean, on the exam, I had something, I don't even remember what it was right off the top of my head, but I had something pretty simple. And it was amazing how many people didn't get it. I was a wee bit surprised. I'm trying to find one. I don't know, it was something in the category of this. That was 6, right? So we'll do 7. Square root of x minus 2 is equal to 3. And I can't tell you how many creative things I did that were, that I saw that were wrong, but it was interesting. I don't know what you guys were thinking, but it is a radical sign isolated. Yes, it's already isolated on that side. That's not a radical sign. Who cares? We're going to square both sides anyway. X minus 2. That gets rid of the radical sign. X minus 2 is equal to 9. So add 2 to both sides. X is equal to 11. Pretty easy, right? So I think these are actually the easiest part of radicals. This is the easiest when you're solving radical equations. You're just isolating the radical and then squaring both sides. Pretty straightforward. I think that's it. Thanks.